Saxon Algebra 1, Lesson 6. Greetings, students. Today we're going to have more fun with signed numbers, and no, that is not John's name for the lesson. I think his name for this lesson is really boring, so, I'm changing it. But just to review, these are problems where we're going to need our ladder in the meadow, right? The birds are singing, the wind is ruffling the daffodils, and we walk through the meadow and find the hole with our ladder sticking up, and we realize it's a number line. It's a ladder like a number line. The step even with the ground is 0, and then it goes up into the positive numbers and down into the negative numbers. And we climb on this whenever we're adding positive and negative numbers. We don't really call it subtraction anymore. We say it's adding a negative number. But this is our tool. John uses a different strategy. He's got a number line and he's got a bunch of dots and arrows. That doesn't help me. So I use the ladder in the meadow. Use directed numbers and the number line to add +1 and +3 algebraically. That's what John tells us to do. What that means is we're adding, another way to look at that is to put the sign and the number in a parenthesis bundle together. The word and means add. And we can easily see, even though this is like a basic problem, my ladder's too short. 3, 4, 5. Just pretend all those words aren't in the way. We jump on at number 1, positive, and we go up 3. 1, 2, 3. Obviously that gets us to +4, right? Example 6.2. Oh wait, no, this is still part of the first example. Now what we want to do is add -1 and -3. I didn't mean to put that in parentheses. John didn't tell us that. But that looks like this. We get on at -1 and we go down 3 more. 1, 2, 3. That gets us to -4. Now, this example illustrates something really cool. Notice that these numbers were both positive and these numbers were both negative. And notice that without referencing the ladder, we can come up with a really easy way to remember how to do these problems. If the signs match, you simply add together the numbers and give it the same sign, right? These two, we just add 1 and 3 is 4, and then 2 negatives means that we get a negative there. Okay, so when it's both addition or both subtraction, we simply add the numbers. And if you want to be technical, what we're adding is the absolute value of the numbers, but I think that just makes it more confusing. And we use the same sign. Okay, this is the rule when we have either both negatives or both positives. And I'm asking you to write this in your notes, but you'll remember this really soon. Now let's look at a different case. This time we're being asked to add negative, I'm going to write it out again, add -2 and +5. Okay, let's write that as a problem. That is, -2 plus 5. Okay, so let's jump on. We jump on at -2, and then we go up 5. 1, 2, 3, 4, 5. That takes us to +3. And then let's do the opposite. Add positive 2 and negative 5, right? We just flip the signs. It's the same numbers, but flip the signs. That will become plus 2 plus minus 5. Let's try that. We start at positive 2, and then we go down 5. 1, 2, 3, 4, 5. That's negative 3. This is a different scenario. These two problems are different. These were with the signs matched. We either had both positive or both negative. This is where we have one positive and one minus. We're going to need a different rule for these. We can't use this rule when we have one positive and one minus. The rule is harder to write out, but let me explain to you what it is, and then we'll figure out how to write it in a short way. When you have one positive and one negative, just look at the numbers and subtract the smaller from the larger, right? 5 minus 2 is 3. Then give your answer the sign of the bigger number. 5 is the bigger number. It has a positive, so that makes it positive 3. Let's try it down here. Ignore the signs, just take the numbers, subtract, we get 3, and then give that answer the sign of the larger number. 5 is larger, so it's negative. So that is the answer. So we subtract, and then we use the sign of the larger number. That's the rule for two different signs in your addition problem. Okay? As we work through these and get more and more practice, that will become second nature to you. You won't have to think about it. Oh, look at that shadow. There's an actual shadow. All right, John gives us 8 problems to work through, so we're going to do that. A. Plus 7 plus minus 3. Okay, I'm going to write them down, and I want you to copy them, and I want you to give them a shot before I tell you the answers. So I'll write them, and then I'll give you a few minutes. Oh, I'm not doing this right. This is actually C. I fixed it. Okay, copy all these down. Then I want you to pause me and work the answers to these using our rule, right? If they're the same sign, you simply add the numbers and give it the same sign, positive or negative. If they're opposite signs, one's positive and one's negative, then you subtract the numbers and give the answer the sign that matches to the larger of those two numbers. All right? Pause me. Start me back up when you have answers. Okay, you're back, so let's go through and get the answers. Here I see opposite signs, so I subtract. 7 minus 3 is 4. And I see 7 is the larger number, and that's positive. Here they're going the same way, right? We have matching signs, so I know that it's 10, I just combine those and give it the same sign. These are going the same way. These are going the same way. These are going opposites. 7 minus 3 is 4. I give it the sign of the larger number. 7 is larger, so it's a minus. Minus 2 and positive 8. The difference is 6. 8 is the larger number, and it's positive. These are going the same way. These are opposites. 8 minus 2 is 6. 8 is the larger number, and it has the minus sign. All right, let me just double check. 4 minus 10 plus 8 minus 10 minus... Okay, these are all the right answers. Yay! Okay, we're going to be doing these forever, so don't worry if you're still kind of like, oh, this isn't the most normal thing. All right, here we go. Now we're going to add more than 2 numbers. Ready? Minus 5. Eventually, we're going to simplify the way that we write these, but John is trying to really enforce something to you that is useful and important. Each package contains a number and a sign. This one doesn't have it written down, but we can imply it. Each set of parentheses is a package that it contains a number and a sign. From now on, our numbers will always have signs attached to them, even if they're invisible, like this one, it didn't have before. But we'll always consider that a bundle. And what John's doing here is saying consider each of them as a separate unit, kind of like a railroad car, and these are the connections between them. For the connections, we always use plus signs now. And if we want to actually subtract, then we attach the minus sign to the bundle. Later, we're going to streamline this so that we don't have quite as much to write down. But for now, even in the next section of this lesson, we'll get a little cleaner. But for now, we will practice this kind of calculation while leaving them in their little bundles. So first what we do is we want to summarize all the positives. So I'm going to circle every term that has a positive sign. Plus 2 and plus 4, I can quickly add those together and get plus 6. Now I'm going to do the same thing with all the negative terms. I'll put a triangle around those. Minus 5 and minus 3. Okay, that gives me minus 8, right? Keep the same sign, just smush the numbers. Now I'm ready in one last step to combine these two, and I get negative 2, right? 8 minus 6, they're opposite signs. 8 minus 6 is 2, 8's the larger number, negative, so that's my final answer, okay? This is one way to add problems like this, is to summarize all the positives and then all the negatives and then combine them. There's another method, and I'll show you that in the second example. Got our rail cars with our bundled sign and numbers, right? Each of these is a rail car, and there are the connections between the cars. This time, instead of combining all the positives and negatives, we're just going to go down the line, climbing up and down the ladder as we go. Negative 3 plus 2, that much is negative 1. Negative 2 more is negative 3. And then here, we add 4 and we get positive 1. So our final answer is positive 1. So you can just work your way down, climbing up and down as the pluses and minuses dictate. I like to make notes because it's easy to forget what you just said. So I make little notes to myself, and then when I get to the end, there's my answer. Both of these answers are correct. This one and this one. Yay. So there are 2 different ways to add trains of numbers, and once you get the hang of it, you can do it however you want. Okay, now let's practice a simpler way to write these things, because we don't want to be writing those complicated boxcars with all the parentheses and extra plus signs if we don't need it. So here is a simpler version. Okay, you can see John's taken out all of the parentheses and some of the plus signs, right? So we can mentally put those back in if we want to. It helps me just to think of each number and the sign in front of it as being a package, right? I don't have to write that out with the parentheses, but I just think of each one as a package and I'm combining them all. So I'm going to add up all my positive numbers. And there's just the one, right? Oh no, this one, plus 2. And then I'm gonna add all my negatives. Notice how I'm just making circles or underscoring lines just to help me see which ones go together. All my negative numbers add up to 4 and 3 is 7, 11, 14, 15. Let me do that again. 7, 11, 14, 15, 16. There we go. That makes more sense to me. And then I can combine these two numbers and get a negative 14. And that's the right answer. Okay? I like this method better than working all the way down. To me, it's easier because we're adding all of the positives and all of the negatives together, and that's easier, right? Adding one positive and one negative is a bit more tricky in my brain. So I like to do the combination method. Couple more. Okay. Again, we want to focus on seeing each number and sign as a bundle, and we're combining them all. Let's do this one. Let's climb up and down the ladder on this. Minus 2 plus 11. That's going to take me to positive 9. Actually, I'm using my rules, right? When the signs are opposite, we subtract 9 and use the sign of the larger one. So that would be plus 9. Minus 4 is going to still be plus 5, right? We take the difference between them, that's 5. We give it the sign of the larger one, it's positive. Plus 3 takes me to plus 8. And then minus 2, my final answer is plus 6. Okay? And then, example 6.7 is one more of these. And I'm going to write it just the way John did so you can see how things can get interesting real fast. Okay, look at what's going on here. Put parentheses around the first number. Okay, that's the train car thing. We're not uncomfortable with that. And then we notice these, he wrote in the simplified way. He did not bother to make those into little train car bundles. All right, well, we don't need them. We can kind of imagine them if that's helpful to us. Or to me, I kind of erase those. This is different though. We haven't seen this today. That's an absolute value. Oh, okay, and I know that what I do is I simplify within the absolute value signs if I can. And if not, remember it's Susie Sunshine, it makes everything positive. So I'm gonna rewrite this as minus 4 plus 2. And all the rest stays the same. All right, then I'm gonna gather up all my positives. That gives me 5 positives, and then I'm gonna gather up all my negatives. Negative 4, negative 7, negative 2. I know I can just add them. 11, 12, 13, give it the same sign. Now when I combine these, I've got a plus and a minus. I take the difference, which is 8, and I give it the sign of the larger number, minus. That's the right answer. Yay! And then the last thing that John wants to point out to us is theoretical. We've already determined this by doing the work, but what he wants to point out to us is that the expression that we used to see as meaning subtraction, we're kind of reinventing, right? We're saying instead of calling things subtraction, we can call it addition of a negative number. Subtraction is the same thing as adding a negative number. Huh. A little trippy, but it actually makes life simpler because we can just call it adding, even if it's negative numbers, all right? John sometimes refers to that as algebraic subtraction because even though it looks like we're adding, we're technically subtracting. All right, good to know, right? That is the end of lesson 6. Go ahead and do all the practice problems and the odd numbers in the problem set. Thank you. Goodbye.